One concept that is really important in physics is conservation. So in this case we're going to talk about conservation of momentum. But conservation, what that means is that the total amount of whatever you're looking at is conserved. What that means is the amount at the end is going to be exactly the same as the amount at the beginning. So if I have a forest and I have 1,000 trees in it, I'm going to conserve it. That means if I come back in 100 years, there should still be 1,000 trees. There should be the same number of trees. And this applies to conservation of energy, which we'll do later. If you have a certain amount of energy at the start, you'll have the same amount at the end. Maybe in a different form, but if we add it all up, it's still the same amount. And same with momentum. Momentum in a collision is conserved. So we'd better explain what a collision is. So in physics, when we're talking about a collision, it's when two things interact with each other. So if we have two cue balls and they click off each other, they go bang, that's a collision. Or if we hit a cue ball and it hits a cushion, like we're playing snooker or pool or 8-ball, we hit the ball, it bounces off the collision, it is off the cushion, it's collided with the cushion. A collision does not have to be a physical meeting of things. We can have two magnets. So if I have a north magnet like this and I drop another magnet on it, this one might just bounce before it even touches that one. So a collision is when two things are interacting with each other and affecting each other. And conservation of momentum is a great way of doing it. So conservation of momentum, PF equals PI. That's all we're talking about. PF equals PI. So let's actually apply this to a collision. Let's do a simple one-dimensional collision. So let's do a problem. A 1D collision. Collision. So I'm playing snooker. Let's play pool, 8-ball, and hit the cue ball at 5 meters per second. I'm going to say the mass of the cue ball equals 100 grams. I have no idea how much a cue ball weighs. It hits the, make it a 5-ball, and stops. How fast does the 5-ball then travel? So what we have here is a fairly common incident that most of us have done at some point. You have the cue ball, you have the 5-ball. The cue ball comes along, hits the 5-ball, so it's going to be a stun shot, boom. So the cue ball stops and then the 5-ball travels on. Boom. And classic, so just step one, draw a picture. And what this one though, this type of thing, whenever you're dealing with conservation, has a past and a future, because it has PF equals PI. That means we've got a start amount and a finish amount. So we draw a picture, start picture. This is the cue ball, this is my 5-ball. This ball is moving at 5 meters per second. I'm going to assume the 5-ball also weighs kg. And the 5-ball is not moving. V equals 0. So what we want to do is we want to find out the total momentum of the system. So the total momentum of the system, P initial equals P1 plus P2. We add up. So I'm going to call this one V1, V2. So we add up how much mass does the cue ball have? So it's going to be the cue ball. V1's going to be cue ball. Okay, so we go mass 1, velocity 1, plus mass 2, velocity 2. Okay, so that's going to equal 0.1 kg, because that's how much the ball weighs, and it's travelling at 5 meters per second. So that's going to have half a kg meters per second. But what about this ball? This is part of the system, so we're going to add that momentum on as well. That's also what, 0.1 kg. Its velocity is 0 meters per second. So we add it all up, and the initial velocity, or the initial momentum, 0.5 kg meters per second. Okay, so this is the before. As PF equals PI, that means that the total momentum in the system, so this is the before, this is the after, the final. What's happening now? The cue ball is now motionless, but the 5 ball is now moving 5 meters per second. And we want to find out how fast is that 5 ball moving. Well, we know the total amount of momentum in the system. So P final equals P initial, which is equal to 0.5 kg meters per second. We've already worked that out up here. P final is equal to mass 1, velocity 1, final, plus mass 2, velocity 2, final. That's all equal to 0.5. Okay. So what do I want to work out? Well, what's mass 1? That's equal to 0.1 kg. Well, don't have to do units in this case. Times 0. Plus M2 is 0.1 times V2 equals 0.5 kg per second. Let's get rid of, because anything times 0 is 0, we can just get rid of that. That means the momentum final, well, using this we can tell 0.1 times final velocity equals 0.5 kg per second. I divide both sides by 0.01. So V2 final equals 0.5 divided by 0.1 equals 5 meters per second. So what this tells us is that these two balls are the same mass. This one comes in, hits this at 5 meters per second, this one stops, and this one moves off at 5 meters per second. And that would be consistent with everything I've seen in reality. So the first one comes at 5, because these are the same mass, shifts on. However, if these are different masses, what's going to happen? And that's going to be continued in the next video.